Hello and welcome back. These will be the video notes for section 10.6, solving using the quadratic formula. There is a PDF available if you want to print it out and follow along, and I highly recommend you use a calculator that does have a square root feature. So in this video we're going to talk about solving using the quadratic formula, and we're going to take a look at the different methods for solving quadratic. First thing is, what is the quadratic formula? Well, you can see it right here in front of you, but one thing you want to understand about it is that any quadratic equation that's written in standard form, and this is kind of key, it's got to be in standard form before this formula will actually work. It can be solved using this formula if there is a solution. So I went ahead and highlighted the important parts, which are the coefficients a and b, and then the constant term c. And that's all that's actually used inside this formula here. And all of that will determine x. And you'll see that there's a plus or minus in the middle here. And that's because you have a square root that involves one positive, one negative, which will tell you both roots. So this formula works for finding the roots of a quadratic. It does not in any way help you factor. But it is the opposite of b, that's negative b, plus or minus the square root of b squared minus 4 times a times c, the whole thing divided by 2a. Let's see this in action then. Example 1, what are the roots of the function? Well, first thing you'll notice is that the equation is not written in standard form, so I got to write that so that it equals 0. So I'm going to rewrite that off to the side. We have a 3x squared plus 5x minus 8 equals 0. Now, one of the things I like to tell students is you should probably identify a, b, and c before you begin. So a in this case is a positive 3, b is a positive 5, and c is a negative 8. That's a reminder to you that wherever you put them into the formula, those are the values you're substituting for a, b, and c. So we're going to start off with the formula. So the first one says opposite of b. So that would be negative times 5 plus or minus. And I'm going to do underneath the radical first and then put the square root outside it. So it's going to be b squared, b is 5, so it's 5, and make sure you put this in parentheses, squared, minus 4 times, and a is 3, and c is negative 8. So I've done this underneath. Now I got to put the square root around the whole thing. And the whole thing is written over top of 2 times the a value, which is 3. And this is simply going to equal the x-intercepts, the roots, or the zeros of the function. So we have to do normal PEMDAS when evaluating this. So we have to go underneath the radical sign and do that first. So we got 5 squared, which is going to be 25, minus, and use your calculator to calculate this part of it, 4 times, it's actually a negative 4, times 3 times negative 8, and that's going to give you a positive 96. So I'm going to change that from minus to plus 96. Square root plus or minus negative 5 all over. And I'm going to go ahead and do the 2 times the 3 and call it 6 right now. Okay, underneath the radical you have a 25 plus 96, so add those together and you'll see we come out with a 121. So we have a negative 5 plus or minus the square root of 121 all over 6. Now you can use your calculator here. The square root of 121 is something you could probably do in your head, but most of the time that is not a perfect square underneath that radical. So what you want to do is round to the nearest hundredth. That's 2 decimal places. So we have 11. This value right here is 11. So I'm going to write this as 2 separate equations. So I got x is equal to negative 5 plus 11 divided by 6, and x is going to equal to negative 5 minus 11 divided by 6. That's where the plus and minus comes from. So I have one positive 11 and one negative 11 for 2 different roots. So go ahead and calculate this first one. Use a calculator. Negative 5 plus 11 will give you a positive 6, and 6 divided by 6 gives you an x of 1. So there's one of your roots, one of your zeros. And the other one is a negative 11 minus, or sorry, negative 5 minus 11, which is negative 16. And you're going to take your negative 16 into the calculator and divide it by 6, and we'll see that this x is going to be approximately, and we're going to use this symbol for approximately, equal to negative 2.67, and that becomes our other root. So we have 2 solutions, one positive, one negative, and one of them is an approximation because I had to round the answer. Example 2, what are the roots of the function? Again, It's not written in standard form, so I'm going to take this x and move it over here. So I have 2x squared minus x minus 7 equals 0. Identify your a, b, and c values first. A value is 2, the b value is -1, and the c value is -7. And now you can drop this into the formula. So the opposite of b, opposite of -1, plus or minus -1 squared, that's the b part, b squared, minus 4 times a, which is 2, times c, which is -7, and we're doing the square root of that whole thing, all over 2 times a, which is 2. Okay, so I have x is equal to, and now let's go ahead and calculate that. The first one here is negative times the negative is going to be a +1, plus or minus. Now I'm going to do these one at a time. This is square root of -1 squared is 1. And over here I have a -4 times a 2 times a -7. Well, negative times negative is going to be a positive. 4 times 2 is 8. 8 times 7 is 56. So that's plus 56. So underneath the radical, I have a 1 plus 56. And 1 plus 56 is 57. So we'll call that the square root of 57 over, and 2 times 2 is going to give, this one down here is going to give us 4. So the whole thing is going to be over 4. Now I'm going to write it as two separate equations, once with the positive, once with the negative. So x equals 1 plus, now here's where you got to go to your calculator, do the square root of 57. And it comes out to about 7.549, so I'm going to round that to 7.55. 7.55 divided by 4. And x is going to equal 1 minus 7.55 divided by 4. And then you use your calculator to calculate both of those. X equals, don't forget you have to do the numerator first, so 7.55 plus that 1 gives me 855 divided by 4, gives me, rounding to 2 decimal places, about 2.14. It comes out to 137, but I'm going to round it to 14. And then we're going to do 1 minus 7.55, and then divide that answer by 4, and we get about negative 1.64. So we end up with those two roots. And again, they're approximations because we had to take the square root of a non-perfect square on this level right there. Example 3, film production. For the period of 1971 to 2001, the number Y of films produced, so Y is the number of films produced, in the world can be modeled by the function y equals 10x squared minus 94x plus 3900, where x is the number of years since, this has got to be underlined here, x is the number of years since 1971. So in 1971, x would equal 0. In what year were 4,200 films produced? So all we're going to do is take this 4,200, which is films produced. Remember, films produced up here is y. And we're going to substitute that y with 4,200. So we have 4,200 here equals 10x squared minus 94x plus 3,900. Now we can use this formula up here, but it's got to be written in standard form. So I need to rewrite this into standard form. So I'm going to move this over to here. So I'll have 0 equals 10x squared minus 94x minus 300. Make sure you use a calculator there. That's 3,900 minus 4,200. The next thing you want to do is identify your A, your B, and your C values. So A is 10, B is negative 94, and C is negative 300. So go ahead and drop them into the equation. So negative B, so negative times negative 94 plus or minus the square root of, and then b squared is negative 94 squared minus 4 times a, which is 10, and times c is negative 300. And we're going to have a large number there. And this whole thing is going to be over 2a, and a is 10. Okay, make sure you use a calculator here. So x is going to equal negative times a negative is going to give us 94 plus or minus the square root of. Now make sure you use a calculator to do these parts. So 94 squared is going to be 8836. And then I'm going to do this multiplication here, which is negative 4 times 10 times negative 300. That's 120,000 plus what I got from this first part. So that first part was 8836 plus 120,000. I'm sorry, that's 12,000. 12,000. And the whole thing is going to be over 2 times 10, which is 20. Now you'll want to combine this together here. So 12,000 plus the 8836 is actually 20,000. So underneath the radical, it's actually 20,836. But we're going to take the square root of that number anyway. So it's going to be 94 plus, now let's do the square root of 20,836, and that's approximately 144.35 over 20. And the other answer will come from 94 minus 144.35 over 20. And use your calculator to solve for both. So 94 plus 144.35 divided by 20. So I get the first answer is an x of approximately, it says 11.91 years. So I'm going to call that about 12 years. And the other x, 94 minus 144.35 divided by 20 is about negative 3 years. In most cases, we don't interpret negative values for time values. That could stand for pre-1971, but this function only works between 1971 and 2001, so we have to kind of ignore this for now. So we're talking about 12 years after. That is not the question they want to know. They want to know in what year. So 12 years after 1971, so 1971 plus 12 years gives you 1983. And 1983 ends up being the year in which there were 4,200 films produced. Well, here we have a list of all the different methods for solving quadratic equations. We got factoring, graphing, finding square roots, completing the square, and the quadratic formula, along with the lesson numbers that match them. Factoring you should use when you can factor the problem easily. If the leading coefficient is 1, that's usually one of the easier ways. But if it's not factorable, then you want to go on to something else. Graphing should only be used when approximate solutions are adequate. However, most of our graphing technology allows us to find out what the roots are without even looking at the graph itself. So unless it's a simple graph that's on a quiz or a test, you probably don't want to use graphing at all. Finding square roots, the key thing about finding square roots, you have to have no b value. In other words, there's no middle term. Finding square roots only works when there's no middle term. Now, if there is a middle term, you still want to use finding square roots. You would then have to go to completing the square. But completing the square generally works best when your leading coefficient of a is a 1 and the b value is even. But we've seen it, we can actually do it when it's not even. So we can do completing the square, which is a form of finding square roots by putting the a and the b values together into one perfect square trinomial. The quadratic formula can be used for any quadratic equation. If you see anything that has crazy decimals, so long decimals, you might not want to try any other methods. Just go right to the quadratic formula. Quadratic formula should not be used if factoring is extremely simple, or finding square roots is extremely simple, or completing the square is extremely simple. So if any of those three methods are very, very simple to figure out, you should try to avoid the quadratic formula because it's going to take you more time to solve for the roots using the quadratic formula. Example 4, what method would you use to solve the quadratic equation? Explain your choices. So the first one here, A, we have no middle term, no b value, so I would use regular square roots. Regular square roots would actually work on that one. The second one, since there's no c value, factoring this would be quite easy because you could factor into x times x plus 4 equals 0, and you have two roots. One is 0 and the other one is negative 4. So I would use factoring here. Some people might want to make the justification that you can do completing the square because the leading coefficient is a 1 and the second one is a 4. Yeah, you can go ahead and complete the square there, but it'll take you a few more seconds to solve than just simple factoring. Letter C here, if I were to do an a times c, so I'd get a negative 20. So if I were to try to list the factors of negative 20 that make positive 9, I don't think I can do that. So this is really non-factorable. The middle term is not even. The first term is not a 1, so you probably want to avoid using completing the square. And the fact that you simply have a middle term, you cannot use regular square roots. So the best form to solve this would be the quadratic formula. Quadratic formula.